Okay, a few words about how standard scores are represented. Remember again that standard scores, when a test is normed, that it was first created, are derived off of from raw scores of the population upon whom the assessment is normed. That is, for example, an assessment such as the self is appropriate for kids, say, in the third grade or third grade through high school. So first, a large group of third graders are given the original version of the self, and each one generates a score, and based on the raw score, how many the individuals got correct on the assessment times the number of points for each item that was correct. That raw score becomes the basis for the derivation of a standard score. And that standard score will be first calculated from a mean that is created. We reviewed this. I went through that quite recently. A mean. And then a standard deviation is calculated with reference to the mean, the standard deviation being the average difference from the average. And then whatever that number is added to the mean of the score once for one standard deviation above, 2 for 2 standard deviations, 3 times for 3 standard deviations above, and on the way down it is subtracted. The standard deviation number is subtracted from the mean once, twice, or 3 times as we go below the mean. Now, for each assessment then, there'd be a different number. Think about it. For any test that is normed and a mean and standard deviation is calculated, not only for every different assessment, but for any different age group within a single assessment, you will get different numbers. Because for each different age group or each different assessment instrument, you would get a different mean based on different raw scores and different standard deviations. Now, wouldn't it be better, wouldn't it be nice for the evaluator if their standard score that gets derived had a name or a number that was the same across different assessments, so that when you looked at that number, you would know, regardless of what the raw score was on that particular test, regardless what the raw score means were on that particular assessment or for that particular age group, you would immediately know, based on the name or the number, whether the child that you're evaluating scored on within the mean for his age or her age, above the mean or below the mean, and how far. Now, you could say, well, let's call the mean Henry. So we can simply say Henry for whatever the mean was, and perhaps one standard deviation above can be Harriet or Helena. But that's kind of stupid. Names anyway are stupid, but numbers would be sound more official and more legitimate. So that's exactly what is in fact done, and that is a Z statistical transformation is imposed upon the numbers, upon the actual raw scores, the mean and the standard deviation numbers based on the raw score. And they are translated into standard numbers that represent standard scores. So when you look at a list of standard scores on a norm-referenced assessment, when you look at those list of numbers, I'm showing you I'm holding up to the camera one of the pages from the PLS 5, Preschool Language Scale 5, and the standard score range scores for children at the age of, what age is that coming in? Am I looking at? Let's scan across the top. Yeah, I can't quite fit it in. It's ages, again, 3. I'm on the 3 to years, 5 months. If you look at the standard score column there, they go from 50 and they go up to 100, and then way up to 150 on that page. That's for 3-year-olds. Now let's jump to a page maybe for 7-year-olds. Let's look at 7-year-olds. And lo and behold, the 7-year-olds there also they go from the same 50, past the same 100, you'll see, the same 100, although they stop at 115, because this test is really for preschoolers, and at 7 you're beyond preschool. But if I go to 4, let's go to 4.6 to 4.11, you'll see within the preschool range, again, the standard scores range again the same exact list of numbers for that age, 50 to 150, I think it goes to. See, just like in the with reference to the 3-year-olds. At 7, just because the test cuts off, simply doesn't go higher than that. It cuts off at 115. Essentially, then, regardless of the age of the child, regardless then of the raw score numbers that were derived to calculate the standard score, another number is substituted, and that number represents, it's then a standard score. It's standard, regardless of the age of the client, and in fact, regardless of the assessment. If I took the self and showed you the page, if I took the Goldman-Fristow test of articulation and showed you a page, if I took an IQ test, like the Wechsler Intelligence Test for Children, and showed you one of these pages, you would find the same range of numbers. We see the following. On many of the standard norm referenced assessments that yield a total language score, which would include receptive and expressive components of subtests, all considered together, you will find the number 100. 100 represents the mean. 100. Similarly, you may have heard the term 100 or the number 100 when you think about, or when you've heard about the average IQ, intelligence quotient, that individuals might achieve on an intelligence test. Well, the same Z-score analysis procedure applies to standard norm reference language tests, these assessment instruments. So 100 is average. You see 100, you recognize that as average. And each standard deviation is translated to 16, a number of 16. So 116 would be one standard deviation above the mean of 100, 132, 2 standard deviations, 148, 3 standard deviations up. On the way down, you find that 100 take away 16 is 84 is 1 standard deviation down, 68 is 2 standard deviations down, and I think it's 52 is 3 standard deviations down if I multiplied my 16s correctly. That's true on the PLS 5, that's true on the self, that's true on the Wechsler Intelligence Test for Children. Now on the subtests, which are on the subtests within the assessment that are much narrower in focus and which include way fewer items than the total test does, on those subtests, assessment instruments that have subtests, such as the self or the told, those subtests also generate standard scores, and usually 10 represents the mean on the subtest. 10. 8 is 1 standard deviation down, 6 is 2, and 4 is 3 on the way down. On the way up, 12 becomes above average, high average, and we go to 14 and then 16 for very advanced. 3 standard deviations up. We'll be dealing with standard deviations down in qualifying children for speech and hearing services. Bottom line, regardless of the assessment, standard deviation scores are in a sense smoothed out and separated from the raw score mean and numbers, so that as an assessor, as an evaluator, we can immediately interpret scores or communicate scores to others, standard scores that have a clear-cut meaning with reference to how close to the mean or how far from the mean, above or below, a particular child is functioning.